My name is Lee Marvin Gulo from VSAT 3A. This afternoon, I will be discussing about the autoflight basic operational principles, autopilot, autopilot engagement conditions, and load thresholds. General. This sequence describes the operational use of the flight management and the guidance computers in a normal operation with a total availability of the concerned functions. The short-term pilot orders are entered through the FCU, while the long-term pilot orders are entered through the multi-purpose unit or the MCDU. So there are four keywords that are input to the MCDU. These are automatic, manual, managed, and selected. Automatic is the autopilot or auto thrust. Manual is pilot action on side sticks or on thrust levers. Manage is targets are provided by the FMGC, and selected is the guidance targets are selected by the pilot through the FCU. Note only that the navigation database is periodically updated. MCDU initialization. First, MCDU status page is displayed, then the pilot uses the MCDU for flight preparations, which includes choice of database, flight plan initialization, radio navigation entries, and checks performance. Mm, while the aircraft is still in the ground and still not in flight, the basic rule is the pilot must enter all this data in the MCDU before flight. So the question is, it is still possible that all these data are changeable while in flight? And the answer is yes, these are changeable, but the pilot must use the FCU and he will change the data he wants, and the data he entered in the MCDU will be override by the new data he input on the FCU. Auto-thrust engagement. Auto-thrust engagement occurs when the pilot moves the thrust levers to the TOGA or FLX MCT gate, then the FMGC automatically engages. The takeoff modes for yaw, longitudinal guidance, runway, speed reference system, the auto-thrust function, but it is not active. The FD symbols appear on the PFD, green FD yaw bar and pitch bar. For takeoff, the levers are set to the TOGA gate or the FLEX MCT gate if a flexible temperature has been entered to the MCDU. Of the thrust reduction altitude, the FM part warns the autopilot to set the thrust levers to CLB gate. The thrust levers normally will not leave this position until an audio message retard request to the pilot to set the thrust levers to idle gate. So autopilot engagement. Either autopilot can be engaged 5 seconds after the liftoff. When the when the airplane takes off, the autopilot will engage in 5 seconds, and the data that the pilot input will be activate, like the navigation, the vertical speed, all the input for the autopilot will be engaged. Only one autopilot can be engaged at a time, the last in being but the last engaged. So basically, there are two autopilots active, and the autopilot one is um is the only one working because the autopilot two is for the reserve only. After the normal climb cruise and descent phases, selection and land mode autoland allows both autopilot to be engaged together. After touchdown, during rollout mode, autopilots remain engaged to control the aircraft on the runway centerline. So after the pilot lands the aircraft, the autopilot will still remain and guide the aircraft through on the runway to the center line, and the autopilot will be disengaged at low speed, and the pilot must taxi the aircraft and stop it. So this is the diagram. MCDU um, up, uh, up to the navigation per database. Light plan goes to the autopilot flight director modes, and down goes to the auto thrust modes. And the side stick and the autopilot is under the FCU flight control computers, while the thrust levers and the auto thrust is in the FADEC engines. General: the autopilot is engaged from the flight control unit (FCU) by the related push buttons. So there are several push buttons on the FCU compared to the MCDU. The MCDU is very complicated, while the FCU is very like to simple to watch, because there are only um, 8 buttons, I think, and four knobs. Autopilot engagement is indicated by the illumination of the Autopilot 1 push button or the Autopilot push button, three green bars by the white Autopilot 1 and Autopilot 2. The loop is closed by the real values coming from sensors given by the systems. When the autopilot is engaged, the load thresholds and the rudder pedals and the side stick are increased. If a pedal or side stick load threshold is overridden, the autopilot disengage. So if one of these pedal or side stick is moved, and the autopilot will be disengaged. There are lateral modes and vertical modes. Basically, one of each is chosen by the pilot or by the system. Engage one lateral mode and vertical mode simultaneously active according to flight phases lateral modes controls. The ailerons via ELACs, the spoilers via ELACs and the spoiler elevator computers, the rudder via FAC, the nose via bunking steering control unit and VSCU. Ground: for maintenance purposes, the autopilot can be engaged on the ground with both engines shut down. Hydraulic power is not required when an engine is started. When an engine is started, the autopilot disengages. So if the engine starts, the autopilot will be disengaged, and the pilot will input another new database on the MCDU, and after flight for 5 seconds, the autopilot um, will engage again. In cruise, only one autopilot can be engaged at a time, priority given to the last engaged. Engaging the second autopilot disengage the first one. The ailerons, spoilers execute the lateral modes, the elevator and the THS execute vertical modes. Note: the rudder is controlled not by the autopilot but directly by the FACs. So basically, there are four basic functions of the FAC. These are the yaw damper, rudder trim, rudder travel limitation, and the flight envelope protection. These are the four functions of the FAC. That is why it stated here that the rudder is controlled not by the autopilot but directly from the FACs, because It is one of the function of the FAC. Um, Landing: If the airfield is equipped with ILS installations, the autopilot can perform a complete landing with approach, flare rollout. A second autopilot can be engaged. Um, AP1 active, AP2 is in standby because the AP2 is for reserve only, and it will be used during if there will be something bad happens. So the AP2 will be engaged. During rollout, the autopilot gives steering orders to the rudder and nose wheel. These orders depend on the aircraft speed. Aileron and spoiler autopilots are null. The THS is reset to 0.5 nose up. Note: the spoilers are directly controlled by the SECs as air brakes. So this is diagram. FMGC to PFD and FMGC to FCU, back to the FMGC, others and radio now, rudder pedals, FMGC, side stick, FMGC, yeah. Mm, Autopilot engagement conditions. The FMGC autopilot commands are processed by the FAC and the elevator aileron computers, and are further transmitted to the brake steering control unit and spoiler elevator computers in order to position the control surface for the pitch, roll, yaw axis on the nose wheel. Disengagement conditions. AP1 or Autopilot 2 will disengage when the takeover PB is either the side stick is pressed, so the pilot must be very careful when if the autopilot is engaged. They must not press anything or move the side stick or the yoke or the rudder pedal because the autopilot will be disengaged. But it is still okay if the autopilot is I will be disengaged, but the pilot must control the aircraft manually. The corresponding AP/PB on the FCU is pressed. A force above certain threshold is applied to the either side stick. The opposite autopilot is engaged except when log, CGS modes are armed or engaged. Rollout or GA modes are engaged. Both thrust levers are set above MCT, letting aircraft on the ground prevent a takeoff, and the following touch-and-go maneuver if one of the engagement conditions is lost. Furthermore, in normal law, with all protections operative, the autopilot will disconnect if high-speed protection is active, um, AOA protection is active, bank angle exceeds 45 degrees, so and rudder pedal deflection is greater than 10 degrees out of trim. Manual trim inputs on the trim wheel. Load thresholds. Each autopilot has its own relays and can therefore lock the controls. Side stick controllers, and B-rudder pedals. Exceeded load results in autopilot disconnection. Yeah. So this is the diagram for load threshold. So that is it for today, and thank you.